Hey, what's up guys? I'm Noam and I'll be guiding you through a review of the periodic table in this video. So the first thing that we're going to be talking about is atomic number, which is the number of protons that each element has. For example, hydrogen has 1 proton, so it has an atomic number of 1. This is the way in which elements are put in order in the periodic table. It's these numbers right here. That would be your proton number or atomic number. Next thing that we're going to be talking about is mass number. This is the number of protons plus neutron, which will give you the mass of the element. Electrons aren't included in this because they're so much smaller compared to protons and neutrons that their mass is negligible. Next thing would be atomic mass. This is different from mass number because atomic mass takes into account the relative abundancy of isotopes, which is this number right here. This number isn't a whole number because of these relative abundancies. It's not because we have 0.94, for example, of a proton or of a neutron. That would be impossible. It just means that this will be the average mass of this element. Next thing that we're going to be talking about is isotopes, which is different versions of elements based on the number of neutrons that they have. For example, carbon would have isotopes of carbon-12, carbon-13, and carbon-14. They all have the same number of protons, otherwise it would be a different element. What differs will be the number of neutrons, which gives them the different mass. So for example, carbon-12 would have 6 protons and 6 neutrons, whereas carbon-14 would have 8 neutrons. Next thing that we're going to be talking about is alkali metals, which is this group right here. They have 1 electron in their valence shell, which they give away in ionic bonds. This group right here is the alkali earth metals, and they have 2 valence electrons in their valence shell, which they give away in ionic bonds. This group right here are the transition metals, and they tend to give away anywhere between 1 to 3 electrons in bonds. This group right here is the halogens, and they have 7 valence electrons, which is why when they form covalent bonds or ionic bonds, they tend to attract electrons to their nucleus because they want to fill out their valence shell. This group right here is the noble gases, and they have a completely filled outer shell, which is why they don't form covalent or ionic bonds. Except on some rare occasions, xenon can form covalent bonds with nonmetals that are very electronegative. So electronegativity would be how badly an atom wants electrons. So atoms right here would be very electronegative because they tend to want to gain electrons, whereas these elements are less electronegative because they give away electrons. Also, noble gases aren't very electronegative because they have a completely filled outer shell, so they don't really want to gain electrons. Next thing that we're going to be talking about is our diatomics. So these are elements that are found bonded to each other, a group of 2 atoms, in their normal elemental form. So that would include hydrogen, nitrogen, oxygen, fluorine, chlorine, and bromine. These tend to be found in gas form, in their elemental form, except for bromine, which is found in liquid form. And that is it for our review of the periodic table. See you in the next video.